Okay, this video is on segment addition postulate. And the segment addition postulate says that if you have a line segment, let's call it A, B, and C. So we have a line segment AC, and there's a point B somewhere, inside. Looks like it's near the middle, but we can't tell if it's exactly in the middle. But it says that if you have a line segment and there's a point inside of it, that if we take this part and we add the other part to it, it'll equal the whole part, which makes sense. So let's say that this part is 6 and this part 7, then that means the whole thing has to be 13, because 6 plus 7 would equal 13. And that's pretty much what the segment addition postulate says, is that this segment, like this part, AB, segment AB, plus segment BC would have to be the entire segment. And it really does make perfect sense. So if we write it geometrically, this is what it says. It says segment AB plus segment BC equals the whole thing, which is segment AC. Notice segment AB plus segment BC would equal segment AC. And that's what the segment postulate says. As long as B lies in between A and C, then this postulate holds true. And of course, that doesn't have to be A, B, and C. It can be other letters, but hopefully you understand. So let's do a different example. So we'll use the same letters just to keep it simple for now. And then we'll do a different letter. Let's see. Let's make this 10 and let's make this 4. So what would AC have to be? What would the measure of segment AC have to be? Well, if segment AB is 10 plus segment BC, which is 4, then segment AC would have to be 14, because 10 plus 4 is 14. Makes perfect sense to me. Now, sometimes they're going to give you the whole amount, and then you're going to have to subtract to find the missing piece. So let's try one like that. And let's say this is 3 and the whole thing is 11. And they want to know what this BC is. So they're going to say BC is what? Now notice I didn't write the line over. That's because when I don't write the line over it, it says something different. Without the line over it, it actually reads the measure of line segment BC. Oops, you can't see that. So it's actually a mouthful. If I put the line over it, it says line segment BC. If I don't put the line over it, it says the measure of line segment BC. So I'm going to say that one more time. Line segment BC. The measure of line segment BC. This is going to be a number. This would be a congruent statement. I would have to use this in some type of geometric statement. I can't use this to say equals 8. I would only be able to use this to say equals a number. So they actually are two completely different things. Geometry can be its own language, almost like a foreign language when you start speaking it and maybe you're speaking broken and people keep correcting you and you think you might be saying the same thing and you get a little frustrated, but you are saying two completely different things when you either put the line over it or you don't. This is a congruent statement. Like you're starting to talk about line segment BC as if you're talking about whether or not it's similar or congruent to another line segment when you put a line over it. When you don't put a line over it, now you're talking about its numeric value. You're talking about the measure. So just keep that in mind. All right, let's keep going. Now, the reason we practiced algebra first is because you're going to be using algebra the whole time in geometry as well. You took Algebra 1 first because you needed it to be successful in geometry. And they're going to give you line segments that look like this. And let's see. Let's say they do this. Okay, so let's say that this part is x plus 3 and this part's x plus 4 and the whole thing is 100. Well, what we know is that if we take this segment and add it to this segment, it'll equal the entire segment. So that's what we're going to do. So we're going to take x plus 3 plus x plus 4. So this portion plus this portion, and we're going to equal the whole thing. So we're going to set up an equation and we're going to solve it. So we put our x's together. We get 1x here, 1x here. We have 2x plus 7 equals 100. And we're going to get a fraction, but that's okay. And then we subtract 7. 100 minus 7 is 93. And then we divide by 2. And 93 divided by 2, oops, not times, is 46 and a half. And that's fine. So the question will be, did they ask us for x, or did they ask us for one of these measures? If they asked us for one of these measures, then we're going to have to plug in x back up here. So I think the easiest thing to do is to just try some of the problems on your assignment. So let's go ahead and take a break from notes and let's start the next video and work out some of the examples on your assignment.